Okay, so today we are going to discuss about the ATP paper, that is paper number 6 in IGCSE. And you know that paper 6 is for total 40 marks, or time duration is same 1 hour, and paper 6 in IGCSE or paper 4 in O levels. So both papers are ATP paper. And from out of 100, there is only 20% weightage of this paper because this paper is easy as compared to MCQs and theory part. For theory, there is total 50% weightage, and for MCQs, 30%. And in ATP, there are specific topics like those experiments that we can perform in labs or school labs easily. So those topics are included in ATP also because we are not taking the practical exams. So that's why we opt this option of ATP. So same pattern questions are included in ATP also. So mostly questions are from physical quantities and measurements, because we can easily use ruler measuring tape in the laboratory to find out any specific length, any specific diameter, or anything related to that. So you will get questions from physical quantities. Second, there are some questions like to read readings from thermometer. And theory is not required for this part of ATP because ATP is alternate to practical. So you have to think like practical possibilities of the questions, practical possibilities of the situation. You don't need to apply theoretical idea, theoretical concept. They only ask about suggestions or how to improve the experiment. They will ask some suggestion questions like this. They will not ask that what happened, just like if we take example of evaporation. So they will not ask theoretical concepts in ATP. It is actually related to the practical experiment that is going to be done in your question, or situation is given in your question. So you have to find answer according to that. You don't need to answer with respect to the theoretical idea behind that whole experiment. And after thermometer, the most important, light and lenses, reflection, refraction. So these topics are included also, plus electrical circuits, how to connect voltmeter, how to connect ammeter. You already know from theoretical idea that we connect voltmeter always in parallel combination and we connect ammeter in series combination. So in electrical circuits, we have idea of electromagnetism, current, electricity, DC circuit. So these basically, these four topics are important. You know that there are total 6 sections. Nuclear space physics is not included. Otherwise, you can see all other topics are included in ATP. First of all, before starting any topic, there are many repeated questions also available in ATP because practical remains same for refraction, practical remains same for reflection, same for Ohm's law. But how to find out the reading, how to plot the graph, because in physical quantity, the first important thing is to draw the graph and to find out the best fit. There are some chances of error also. So what are the measuring instruments we use and how we measure the length or how we measured a small length, large length. So in this way, we will discuss what are the types of errors also, that what are the chances of getting error in the practical experiment, because when you are performing practical by yourself, so definitely there is a chance of getting errors or getting mistakes during the practical. So basically, the first type of error is systematic error. And you don't need to learn all these points, right? These are just for your reference. You don't need to learn all these points. These are just for your like knowledge based concept, that it will help you that this is type of error and this occurs due to this or that problem in the experiment. So systematic error by name, you can identify it is related to the system. Like if you are using ruler, right? Let's suppose if you are using ruler, but ruler is not starting from zero, right? Like it is broken from zero, or like there are rough marking on it. So when you got error in your reading, so that is due to system, right? Because the experimental apparatus you are using, so that is already faulty. So definitely that will also produce error in your readings also, right? Or sometimes you are not correctly read like taking the reading from the ruler. For example, if we zoom in the ruler, so you know that between 0 and 10, how many divisions are there? There are total 10 divisions. And if they ask you to find out the minimum length that we can measure from this ruler, so what is the minimum length we can measure from this ruler? 0.1, right? Because you know there are 10 divisions. So there are 10 divisions between 0 and 1. It means one division is equals to zero point 0.1, right? And let's suppose if you are reading or you are taking reading from the ruler or from the measuring tape like 1.001. So that is not possible, because there is no chance to take reading of 0.01 from the ruler, because there is no division present in this ruler, right? Because in theory we know values are given. So we don't need to find out value by ourselves. But let's suppose if they ask from this ruler that how to read the reading or to find out the reading. So you know the minimum value we can record from this ruler is 0.1. So either your value is 1.1, 1.2, 1.3 like this. Okay, it will not like 1.21, 1.34. This is not possible, right? Because there are no such divisions marked on the ruler, right? So let's suppose if you are taking wrong readings or like wrong observation from the ruler or any apparatus like this, so that is called systematic error, right? So basically systematic error includes the errors in your instrument, or maybe equation is not correctly written for the calculation, because in this ATP paper you already got formula to find out unknown quantities. You don't need to apply formula by yourself. Let's suppose if they ask you to find out electric current, so they give you the formula of Ohm's law, V is equals to IR by their self, right? So you don't need to learn the formula for ATP also. Or let's suppose your method of using that equipment is wrong, so that will give you systematic error. Because when they ask about suggestions or when they ask about problems, that what are the possibilities that you will get error, so this will help you to write down like key terms that this error occurs due to systematic error or like personal error. Or there is also one more category which is important, zero error. So the concept of the zero error is very simple. Like when we visit market or any shop, so there is electronic balance placed over there. Sometimes it happens when there is nothing placed on that electronic balance, but still electronic balance shows some reading like 0.05, but there is nothing placed over it, right? So it means it already shows some reading, but there is no matter, there is no object placed on it. So it means there is zero error in the device. Okay, your device or your instrument is not properly set to zero. Just like the example of a stopwatch. If you have to take reading from the stopwatch and your stopwatch is not set to zero, let's suppose previously you take reading and it is equals to 18 seconds, and you start new reading from there, so it means there is zero error in your instrument because you not set your device to initial point which is zero. So this type of error are called zero errors. Okay, and one more thing in the same diagram.
Oh, okay.
Yes, we will discuss that part in question also. These notes are just for your reference that what are the important points that we have to keep in our mind during the experiment. And if we take the example of this ruler again, so in this ruler you can see this X point is marked over here. This is marked over here because let's suppose if someone asks you to measure the length of a box, right? So there are two possibilities. Most probably what happened that a student just place box over here like this. This is a rectangular box and they ask you to measure the length of it. So what is the problem in this? We are not starting our reading from zero, right? Because the zero scale starts from this position. And we just placed box on the bench or the surface of that table, and we just start recording the reading, and you will get reading 5 centimeter. So this 5 centimeter is not the right reading. And what is the reason? Because we not start or we not place that object at the zero of the ruler, right? For correct reading, what we have to do, we have to place at this point. So then you will get accurate reading starting from zero until this point. Okay. So 6 centimeter is actual length of this rectangular box. So these are very minor things that you have to keep in your mind while taking the reading from the instrument. And this is not required because we are not performing practical physically. If you are performing practical physically, so then these points are important because readings are already given. So these two types of positive error and negative zero error is not required because you don't need to correct the values. If there is some correction given, so that that is already mentioned in your question. Okay. Next important thing is random error. In random error, we have a human error and parallax error. Human error we already discussed. If you place a object at a wrong position and then you start measuring the length, so definitely you will get wrong length of it, right? But if we talk about the parallax error, so this is the example of parallax error. So in this example, you can see there are two different observation. The first one is the correct observation and second one is the wrong observation. So sometimes in question they ask you to draw eye, right? Just like the same. So in some questions, they ask you to draw eye that at which point we have to keep our eye to record the reading. So in that part, you have to keep things in your mind that always ignore this parallax error. Always record reading from the front, not from any other angle, right? Because you can see this wrong observation is at a certain angle from the original point. This is object, and of this object you are measuring the actual length. So you have to record that reading from the front, right? Not from any other angle. Like if object is placed in front of you and you are standing right, like 45 degree towards right or 45 degrees towards left, so definitely you will get different reading. Okay, like there are four students standing beside the bench, and the student which is in the center, so that student will get exact reading, but the students on the right and students on the left will get different reading because of parallax error. The same example, right? So this is a very important parallax error, because in most of the questions they ask suggestion and what is the problem in the experiment or what are the chances of getting error. So in most of the questions we got parallax error, and this is the most probable type of error we got in the experiment. So this is important, and previously we discussed the handling of the apparatus, that how to place object, how to record reading. Plus, there are, and we already know, the concept of taking the average value, right? Because in theoretical idea we already practice this concept, that always take the average of the reading. It will not like just record one reading and that is final. We record like 3, 4, 5 or 10 readings, and then we take the average value to uh, remove the error from the readings. And there are some other instruments also, like ammeter. So we know that ammeter connects in series combination with the circuit, right? And if we talk about voltmeter, so we have to connect voltmeter in parallel combination, right? Then we have meter rule and measuring tape. Meter rule, is it is a type of rigid apparatus, right? We are not able to like curve that object. Meter rule is like a solid rigid object. So we just record a straight length from the ruler. But let's suppose if you want to record length of a wheel, like circumference of a wheel. So when we have to record the circumference of the wheel, so definitely we require measuring tape, right? It cannot be possible with the meter rule, because meter rule is rigid and we are not able to rotate around the wheel or any like sphere object. So for sphere object, we required measuring tape, right? So we use meter rule for regular or like perpendicular or linear objects. And if we want to record the length of curved surfaces, so then we have to use this measuring tape. Let's suppose if the example of wheel is given or any sphere is given, and they ask you to state the name of the apparatus that is helpful to record the circumference of the wheel or that is sphere. So definitely you will write measuring tape, not meter rule, because meter rule is not able to record the circumference of that wheel or sphere. And after that, if they ask you to write down the name of the apparatus used to measure the volume. So we already studied in mass, weight and density chapter that we use measuring cylinder to measure the volume of an object or any liquid, sorry, or any irregular object. And there is one more important apparatus, that is set square and meter rule. So why we are using set square in the apparatus to measure the length? So let's suppose if you have a spring or any thread connected with some rigid body, just like in this example. So you can see spring is connected with some rigid body and ruler is at a distance from that spring. So we are not able to measure the length of that spring with ruler, because if you hold ruler by your hand, so definitely there is a chance of getting a wrong reading from it. So what happens? We just fix ruler on one end, and with the help of this set square, we record the exact reading on it, that what is the length of this spring with the help of meter rule. But to get exact reading, we use this set square. So in this way, we use set square to find out the length of spring, length of thread, or any hanging body with the rigid body, right? And all of you also know that why we use protector, definitely to measure the angle.
Wait, sir, can you repeat?
Basically, if they ask you to measure the angle of anything, so definitely we use protector or D, right? That we also got in the geometry box.
Yeah.
So always we use this instrument to measure the angle of anything, because in light section we know that there are so many concepts of angle. So definitely we required protector to measure the angle of any incident ray or any type of experiment which is linked with the concept of the angle, right? So basically, till now there is nothing new for you. Just like there are some terms like systematic error, parallax error. These are the terms you have to keep in your mind. Otherwise, you know this idea that how to record the reading, how to measure the length, how to measure the angle. So we already know about these things, right? So that's why in ATP you have to keep your approach practical, not theoretical, right? This is the main important thing. Plus, we are not going to use this because we are not performing again practical physically. So some quantities are not always required in ATP, but that are just for information. And the most important thing is, and this is just one example of like taking the value of oscillation, and you already know how to take the value of oscillation, the point where it starts to oscillate. So when it moves in forward direction and when it comes back to original position, so then we record one oscillation, right? So this is the idea of oscillation, that how to record the oscillations from the pendulum or any body which is hanging with the string or any thread. And after that, this part is important. And why this part is important? Because this all information is related to the graph. When values are given, so definitely you have to plot graph by yourself, because there is also a topic of a speed time, distance time graph. And in Hooke's law, there is also graphical representation of a spring. So we already studied about different types of graphs in our theory also. So whenever they ask you to draw the graph, so that graph is for 4 marks maximum. So if you get the question for graphical representation, so that question is of 4 marks total. And there are two types of graphical representation. Either it will be linear, or second one is the curve, right? I will also share the example of that linear and curve graph. So the first mark you will get in this question is for labeling. Like which quantities need to be placed on x-axis, which quantities need to be placed on y-axis. And that is also mentioned in the question. Let's suppose if you are performing experiment of Ohm's law. So potential difference electric current is given. So they tell you that place potential difference on x-axis and electric current on y-axis. So you have to follow that instruction, right? You don't need to make axis by your own. You have to follow the instruction given in the question. Then you place voltage on x-axis, let's suppose, and electric current on y-axis. Plus, you also need to mention their units, right? Let's suppose if you are writing velocity on any axis, so definitely you need to mention the SI unit. Either it is given in centimeter per second or meter per second. So always write units, just like we got in theoretical question, graphs in theoretical question, you observe that proper readings, proper units are given in theoretical questions graphs, right? So we have to do the same thing. Plus, second mark is for correct scaling. Sometimes scaling is already given on the graph, but most of the time graph is completely empty. You have to take values on x-axis and y-axis by yourself, because they also want to assess that how you complete graph by yourself from start till end. Okay, no issue. I'm recording this meeting also. I will share the link after the class, so you may revise the misconcept from that. And the third point is, definitely, let's suppose if you are marking 2 centimeter on the graph, so definitely we required either point to mark on the graph or cross. So there are two options. For plotting point, either you have to use this dot and make circle over it, so it will be visible. Otherwise, you have to make just cross on that point. So it is like easily visible on the graph for examiner. And the final mark is for if they ask you to draw a best fit line, like a straight line, or if your graph is curved, so they will ask about the curve of best fit. We will also discuss what is the concept of this best fit. Before that, let's suppose if you graph is given on full scale paper, like one complete paper, you completely gets graph from start till end of the paper. So in that graph, you don't need to like make half of that graph or just draw axis in between. You have to use at least 70% region of the graph, right? It means you have to make like easy open graph on the paper. Don't make very shrink points that only like all the points are marked in half graph. So that is not acceptable, right? So try to make open reading graph, and readings are like very easily marked on the graph, so it will be visible clearly, and it will also easy for you to join the points and mark points on the graph. So at least 75% region of the graph has to be covered, right? So this is one more important point. And axis should be linear. Axis should be linear means, let's suppose if you are marking the values on the graph like 0, 4, 8, 12, 16. So now you can see there is a difference of 4, right? So this is correct. But let's suppose if you are marking readings like this 0, 4, then 10, then 16, then 22. So there is no pattern in this, right? First there is a difference of 4, then 6, then again 6, then 6, then again 4. So this is not a correct way to scale your axis. So this is the concept of linear, right? It may be different, like on x-axis you are using different divisions, on y-axis you are using different division, but that should be linear. It is not like you just take the values from the table and just copy paste that value on the graph. So this is not the correct way. You have to make proper distribution on the graph, right? And try to take even values like 0 to 4, 0, 4, or round off values like 5, 10. So try to avoid even odd numbers like 1, 3, because you know that if there are 10 divisions and you write 3, so it will be very difficult to mark exact value, because if you divide 3 into 10 divisions, so it will be equals to 3.3333. So then it will be very difficult to mark exact reading on the graphical representation, right? And sometimes examiner also asks you to draw the graph, and it is not compulsory that always starts from 0. Let's suppose if reading in the table is given 20, 40, 60. So you may start your graph from 20 directly, right? You don't need to mention 0, 20, 40. It's up to you. It is, this instruction is also given in the question. Okay. So these are some important things related to the graph also to keep in your mind. Then the concept of a best fit. So when we have to draw a lines or a curved line for best fit, so these are some example of best fit line and best fit curve. So in the first diagram, this is for best fit line. And you can see that in this diagram, this line only, this line is not passing through any point, right? All points are like away from the given straight line. Okay. Basically, the idea of the best fit line graph is that your line follows the trend of the point, right? So basically, in this graphical representation, line tells you about trend of the values or observation given in the table. In this line, you can see there is 1, 2, 3, 4. 4 points are on the left side of the line or on the upper side of the line, and same 1, 2, 3, 4. 4 points are on the lower side of the line. So basically, this line shows you the trend. It is not compulsory that to connect all the points in a straight line. Let's suppose if you try to connect all the points in a straight line like this. So sometimes we used to make graph like this. So actually what happens? There is nothing on the upper side. All the points are on the bottom of the line. So this will not show you the correct trend of the values given in the table. So it is not compulsory to always connect all the points given in your graph. But 99% in 99% question, it happens that 99% points you will get on a single line. Okay, so basically what we have to follow in the best fit line, try to as many points online as possible. But if it is not happening, in most of question, like 99% it will happen, you will get all the points on a straight line, right? Because you know that it is the first type you are attempting paper like this. So that's why most of the question you will get uh, in easy way, that all the points are already on a single line. But let's suppose if your points are not aligning on a single line, just like in this example, there is not a single point on a single line. So what you have to do, you have to mark remaining points to scattered. Equally about the line, right? Any confusion?
No, sir.
Okay. So these are some concepts related to the journal physics idea, basically, because we discussed all the things about journal physics concepts, right? Like physical quantities and measurements. Now, let's try some question related to journal physics, because in journal physics concepts, like in physical quantities, there is only a typical thing, that is to draw graph, right? If you are good in that, so there is no confusion, there is no problem for you, because in thermal there is no specific type of theme that you have to follow. When you try question by yourself, you will automatically get idea that how questions are for a specific topic. Now let's try, if you try some questions. Let's suppose if we try this one with the easy one. This is from October November 23. So in this question, sand is granular material composed of very small, irregularly shaped mineral particles. A student determines the density of sand by two methods. She uses the apparatus as shown in figure 1.1 and 1.2. So you can see these are two different diagrams. There are two top pen balance. And after that, there are two readings also given in the diagram. In the first, we are getting 76. In the second, we are getting 219. Okay. Now, method one. So basically in method one, it is mentioned the student measures the mass of a 250 centimeter cube measuring cylinder as shown in figure 1.1. So basically the first measuring cylinder is of 250 centimeter cube volume. So this is the value of the volume, right? Given for the measuring cylinder. She pours sand into the measuring cylinder and measured the mass of the measuring cylinder and sand as shown in figure 1.2. And use values shown in figure 1.1 and 1.2 to calculate mass of the sand. Okay. So now you can see complete information is already given. You don't need to use any formula, any theoretical knowledge in this to find out the unknown quantity. So basically it is very much clear. First we place empty measuring cylinder, right? This is empty. Information are like slightly lengthy. So on screen, maybe it will be slightly difficult for you. That's why I'm writing all the thing. So the first image is for empty one. And then in second diagram, you can see there is a sand. So what is the value of the empty measuring cylinder? That is 76, right?
Yeah.
And when we fill sand in it, so you will get reading 219. And they are asking about the mass of sand only. So what is the mass of sand?
143.
143.
143, right? Because 219, 143. And you can see SI unit is already given, right? Okay. So now the student measures the volume V1 of the sand in the measuring cylinder. So V1 is already given. Calculate the value for the density 1 of the sand sample. Use the values from part A1 and use this equation. Now you can see formula equation is already given for you. So you just need to use this information for your calculation. And you have to find out density. So you can see M is written and only M is given in equation also. M1 is not written, right? So complete information is already given. And volume 1 is 108. So just use this equation. 143 divided by
1.32.
1.32. And SI unit will be gram per centimeter cube. Now, a magnified image of this measuring cylinder is given, but this time we have sand sample plus water, right? And in magnified image, you can see the level of the water is given. In chemistry also, you studied about upper meniscus, lower meniscus, right? So we have to record the reading from upper meniscus definitely. And let's see what they are asking about. Now, a student pours a 100 centimeter cube of water cylinder containing the sample of sand, some of water soaks in the sand, and she waits for the water level to become constant. Record the reading V2 of the water level in the measuring cylinder shown in figure 1.3. Now you have to record the value of volume. So now this part is important. There are only 1, 2, 3, 4, 5 divisions, right? 5 divisions means this will be 152, 154, 156, 158, then 160. So this is the only important thing that you have to keep in your mind because most students like do 150, 151, 152, 153. So maybe they record readings like this. So first of all, check the divisions, then the distribution of the division, and then record the readings. So this is the level of water. And this is equals to 154. So simple, 154 centimeter cube. Now in next part, calculate another value for density 2 of the sand sample. Now they also mention the reference that which value you have to use, A1, B1, and this is the equation. And value of K is also given. So we calculated in A1, A1 is, I think, mass. Yes, mass is 143. So this value is equals to the value of the mass, and B1 is this V2. And you can also identify from the equation. Now just substitute all the values in the given equation. You will get answer 143 divided by 154, and the value of K is 100. So 143 divided by 54. So what is the final value you are getting? 2.65. 143 divided by 54. 2.648. Okay, normally in a theoretical paper, we used to write answers. We try to write answers in two significant figures. But in ATP, it is not compulsory to write all answer in two significant figure. You may also write your answer to three significant figures also, right? So 2.65 is also fine for your answer, right? And the SI unit. Okay. So you can see 2, 3, 4, 5, 6. This is 6 mark question till now. In third part, on figure 1.4, draw an arrow showing the correct line of sight for reading the volume of water in the measuring cylinder. So you have to draw an arrow that shows you correct line of sight. So what will be that line for correct observation of sight? This is the concept of that we discuss in parallax error, right? We always used to read readings like this, always perpendicular to the surface. So that will be, this is the line, right? You can also draw on the other side. It's up to you. It is not compulsory that you have to draw on right hand side or left hand side, because instruction is not given. Another student wants to determine the density of the particles in a similar sample of sand. So another student in similar sample of sand. Explain why method 1 would not be suitable method for him to use. So these types of questions are related to like little bit brainstorming. So what is method 1? In method 1, we are doing like this. We just take empty measuring cylinder, then we use simple sand, and we just record the value of mass and the volume, and we apply formula of density mass upon volume, right? And in second example, we take sand plus water and record the level of water from the measuring cylinder and the same mass, and we subtract it from the constant value K, because like we have to subtract the mass of the water. So volume of water is not included in this reading, right? So what do you think that why method 1 is not suitable? If you just check that diagram, so answer or the hint of the answer in this diagram. So basically the problem is, if you observe this surface, this is not flat, right? Let's suppose if someone is taking reading from this point, but this level is at a different point. So there is a chance of error, right? And when we use water, so water helps to get exact straight line reading from the ruler or from the measuring cylinder, right? Okay, so they are also asking about two possible cases of accuracy, sources of inaccuracy. Okay. And any other idea in your mind related to the first diagram, why first method is not suitable? So you will also use that idea that might be there is a chance of gap between the particles, and due to gap between the particles, maybe that sand is not completely leveled. So that's why we are not getting exact reading from the measuring cylinder, right? So that's why method one is not suitable for the student to record the value of density. So sand particles, and if we talk about method number two, why method two would give a more accurate value for the density of the particles in this sample of sand? So basically, in second method, the problem that we discussed in the first method is that might be is some gap between the particles of the sand. So when we use water, so in explanation it is already mentioned, some of water soaks into the sand. So when water is soaked by the sand, so definitely the gap between the particles already filled with the help of water. So that's why second method is more accurate as compared to the method one. And if there is some air particles between the sand present, so that will also covered with the help of the water particles. So water displaces air particles or fill the gap taken by the air particles. And in last part, describe two possible sources of inaccuracy in the measurement taken in method one or method two. So in method one, we already discussed that sand surface is not flat. And basically, the measuring cylinder we are using is like uh, the graduation of that cylinder is very much high as compared to the quantity of mass or the quantity of that material we are recording the volume from that measuring cylinder. And I will also share that file with you. In that, all this type of precautions are already given for measuring instrument, for meter rule, for ammeter, for voltmeter. So from that file, you will also get some ideas that what are the points that we will write in the suggestions, or that will give you the chance of inaccuracy. So when you solve question, when you read that file, so you will got more idea that how to write the point in this type of questions. So measuring, because again, if your graduated cylinder is very much empty, so there is a chance of getting air particles, and some air particles will also give you the mass of air particles with sand. Okay, so there is a chance of like error, because we will also record the value of some air particles with sand. So that's why the height of that graduated cylinder must be like less, or we have to fill more sand in it to get accurate value, right? We don't need to write the reason, because they only ask describe two possible sources of inaccuracy, right? They are not asking about the reasons, or to explain the reason that why it is happening and why you are writing this point. So this type of question you will get in physical quantities or in journal physics type questions. And if we consider one graphical representation question, this one, so it will also give you idea that how to draw the graph for the given values in the question. So in first question, a student determines the weight of a meter rule using a balancing method, meter ruler. So this is the setup we use. Basically, this is related to the turning effect of a body, and we know that how to find out the weight. But still, again, we don't need to apply any theoretical knowledge. The student places the meter ruler on the pivot, and she places a load P on the meter ruler at 90 centimeter mark. She adjusts the position of the meter ruler on the pivot so that the meter ruler is as near as possible to being balanced. So meter ruler is like very close to the balance point or in equilibrium. After that, the ruler balances with the pivot at 75 centimeter mark. Calculate the distance A from 90 centimeter mark to the pivot. So we have to find out this distance A from 90 centimeter mark. So in diagram, you can see A is already given over here. And this is the pivot. And it is mentioned she balances meter ruler at point 75 centimeter. So this point is 75 centimeter and object is placed at 90 centimeter. So they are asking about distance A. So distance A is 15 centimeter away from the pivot, right? So this is simple idea. And we have to write over here in table 1.1. because there is no space given for the value in the first part. So record the value of A in the first row. So you have to write over here a round of 15. Second, she records in table 1.1 the distance B from the pivot to 0 centimeter end of the meter ruler. She repeats the procedure, placing the load P at 80 centimeter mark, 80 centimeter mark, 75 centimeter mark, 70 centimeter mark, right? So these are the values. So 75, 71.9, 68.8, 65.6, 62.5. So these are the values given. Plus, now we have to plot a graph of A on y-axis. We have to take the values of A on y-axis and the values of B on x-axis. Start the y-axis at 0. So you can see instruction is completely given. You have to start your y-axis at 0 centimeter and start the x-axis at a suitable value for the results. So on x-axis, it's up to you that you have to use suitable values, but on y-axis, it is clearly mentioned you have to start your axis with 0, right? So now again, you are getting 4 marks. So we already discussed how to complete the graph for 4 marks. So on y-axis, first of all, we have to start from 0. And the values on y-axis, these values have to be plotted on y-axis. So minimum value is 7.5, maximum value is 15. So we have to keep in our mind that we have to cover this 15 centimeter within a graph, and at least we have to use 75% of graph, right? It is not compulsory that you plot 75 at, sorry, 15 at the top, but at least more than 50% and close to 75% you have to use. Now you can see this is the graphical representation. We have 10, 20, 30, 40, 50, 60, 70, 80. There are total 80 small boxes given on y-axis. And these are the values. So you have to plot like this. So it will be easy for you to plot 7.5, 13.1, 11.3 also in graphical representation. So on y-axis, there are total 8 large boxes are given. So what values you will suggest to mark on y-axis starting from 0?
Can you show the points again, please?
Okay, these are the point. If you have notebook, so you may note these point on that. So it will be easy for you. So these are the points. And if we mark like 2, 4, 6, 8. So let's see, is it possible or not? So if you mark 2 over here, four, 6, 8, 10, 12, 14. So if you are marking like this, so you will get easily 15 on your graph. And otherwise, the second best option is to mark like 4, 8, 12. But again, that will give you 50% of the graph. If you mark, like if we start from 4, let's suppose 4, 8, 12, 16. So you can see we are using less than half of the graph, right? This area will be covered and this area will be empty, right? So if you are marking 4, 8, so that is not like a good scale, good access for you for your graphical representation, because it will only cover less than half of the graph. And again, if you are using odd values, so it will be difficult for you to match exact point or exact marking of the y-axis on the graph. So the difference of two is like the easy one for us to find out all the values and mark all the values. And the value we have to mark on y-axis is a centimeter. So you clearly mention a centimeter on y-axis. And on uh, x-axis, so there is no restriction for x-axis, it's up to you. And you can see your graph is starting, the minimum value on x-axis is 62.5. So if you are starting from 0, so that is not like recommended, because 0 till 62 there is nothing. So definitely we will, if it's your choice, if you want, you can start your graph from 60, right? Like 60 and 62, 64, 65, whatever the value you are taking, because maximum you have to cover 75 on your graph. Okay, so let's suppose if we start from on y-axis, we are marking 62, 66, 64. It is not compulsory that you also need to use the same value. It's up to you. If you find something easy for yourself, you can go for that also, right? But it's still remember, at least cover 75%. Otherwise, you will like lose 1 mark for your graphical representation, or maybe more than one, because definitely you are not able to correctly mark all the points and show the trend of the line also. 76, and the maximum value is 75. So we can see more than 75% is easily covered on x-axis and on y-axis also. And on x-axis, we are using b. Plus one more important point, always plot graph with pencil. Okay. Now let's start with 15, 15, 75. 15 is over here. Let's mark it with different color. So this is 15 and 75. 1, 2, 3, 4, 5. This is 75. So you need to match these lines. Right? So this is the first point. And the second point is 13.1, 71.9. 13.1, 71.9. So 13 is, this is 15. Then 13, this is 13. And we have to mark 13.1. So 13.1 is like between 13 and 13.2. So this will be in between over here. And on the other axis, we have 71.9. So 71, this is 71. And again, in between, we get 71.9. Because when you get a physical paper, so it will be easy for you. On screen, we have to scroll again and again. So on intersection point, this is intersection point. Right? So this is the second one. And the third point is 11.3, 68.8. 11, this is 11. 11.3 will be again in between. Sixty-eight point eight. 68.8. This is 68.8. Right? So this is another point. If your labeling or scaling is right, so definitely you will not get any confusion in marking all the points. But if your scaling is not good, so definitely you will get confused in marking the points. 9.4, 65.6. 9.4, 689. 9, 9.2, 9.4, 65.6, 65.6. Sorry, this is 67. This is 65. 65.246. And final point, 7.5, 62.5. 7, this is 7.5 and 62.5. 62, 64, 62.5. 2.5. 2.5. So this is the graphical representation, right? Draw the best fit line. Now you have to place your ruler on screen, and if you find all the points in a straight line, so join them. Maybe all points are not on a straight line, then again you need to follow the idea of trend. But in most questions you will get all the points in a straight line. Yes. So I'm marking on screen, maybe slightly markings are not accurate, but on paper it will be easy for you. So in most of the cases you will get same graphical representation. You will get all the points in a straight line. Okay, so you don't need to worry about it. And you also observe it is not compulsory always that your graph starts from origin, right? Because in this graphical representation it is not starting from origin, so it is also not compulsory. Then in part C, determine the gradient of the graph. Show clearly on the graph how you obtain the necessary information. So you have to mark all those points on graph also, from where you got that information, the triangle method actually. So let's suppose if we consider these points, like this. So this is the point we are taking for x1, y1. On x1 it is equals to this line 63.4, and on y1 it is 8. And for the second point, this one, x2, y2. So x2 is 76 and y2 is 15.8. Formula of gradient y2 minus y1. x2 minus x1 is equals to value of y2 is 15.8 and 8. X2 76 63.4. So these are the values we recorded from the graph. Will be 15.8 minus 8 divided by bracket 76 minus 63.4. Zero 0.62. Right? So this is the gradient. In option in part D, the weight of the meter ruler is numerically equals to 2g. So it is equals to 2 times of the gradient. So what will be the value of W? 2 times G, it will be equals to 1.23. And if we check marking scheme also, let me show you the marking scheme. October, November, this is 6-1. 6-1. So you can see marking scheme for ATP will be like this. First value 15 is correct. And for the other one, you can see all the points, good line judgment, thin continuous line, all plots correct to half is small square, suitable scale, axis correctly label, right way round. Then for gradient also, no value is given, right? Method shown clearly on the graph because all students record gradient by according to their selves. Some will take different points, other will take different points. So there will be no chance of getting same values on the graph and same gradient from the graph also. But in value of W, you can see there is a range of 1 till 1.4. So minimum answer will be 1, maximum 1.4 if your graph is correctly marked and all the axes on the graph are correctly labeled. So then your answer will be in the range of 1 and 1.4. Like in our case, we are getting 1.23. So it is in the range of 1 and 1.2. Okay. So in this way, you have to draw graph and complete your information related to the graph. And now let's see the remaining part. Suggest one practical reason why it is difficult to obtain accurate readings for A and B. Practical reason, right? Not theoretical. So basically when load is placed, right? So one thing you observe in the diagram also that we have to mark from the center, right? Because this line shows you that we have to read reading from the center of the object. So when we are reading the values, so it might be difficult for us to locate the exact center of the load, right? So there is a chance of error. It will be difficult to locate. The center point of the load. Okay. And the next one is using only the apparatus provided. Explain briefly how you would determine the position of the center of mass of the meter ruler. So how to find out the center of the mass of meter ruler? It is very simple. Basically, we have pivot point and meter ruler. So the simple method is to just place a meter rule on this pivot point when
Make
you,
sure to balance it
yes, when you feel that both sides are
about 50
completely
centimeters.
balanced, right? So if it is 100 centimeters, so definitely you will get 50, but sometimes the distribution of mass is not exactly same on both sides. So we will get a different pivot point sometimes. So place the meter ruler on the pivot and balance it. So when you got the balance point, so that will be your center of gravity. So these are some types of questions that are going to be asked in the physical quantities idea. The most important thing is for graphical representation. So after the graphical representation, the other questions you observe that all the readings, all the formulas are given, and you have to just use those values. And they sometimes ask about the suggestions, to write down some suggestions for the experiment. I will also send the PDF file of the notes for ATP also. So that will also help you to read that, and you will get idea what are the important points that we will use for the suggestions and to write down in the planning experimenting problems. And in new questions, like uh, in new papers, you will get question number 4, which is a type of planning question, right? We will also practice that. That question looks like this. This is the type of question. So, question number 4, you will get like a planning question. All apparatus, all the points, all measuring quantities are given, and you have to write down complete information that how to start the experiment, how to record the reading by using apparatus, how to conclude the final values. And from ATP, now you got idea that we have to take sets of reading and draw graph to find out the gradient or to find out the final result. So these are some important points. We will also discuss this planning question separately. Like on one day, we will only practice different types of planning question, because planning question may be asked from physical quantities, it may be asked from thermal, it may be asked from light, plus it may be asked from uh, like the mixed concept of thermal plus some other quantities. But the other types of questions are like same. You can see this is again same type of question, slightly different orientation, but again the same concept of pivot. Again, values are given, graph is given, plot P on y-axis, plot X on x-axis. Again, they ask about the gradient, explain briefly.
Sir,
Mhm.
there is this one question where they ask you to draw the length and to show how to draw that. It was very difficult for me. They gave you the length in centimeters कि यहाँ बनाना है, and I
Mhm.
did do so, but like मेरा गलत हो गया था. I can
Light,
send you the question. I have it. Yeah, it
okay.
was light rays and then it was like refraction and reflection. Though it was very
Hmm.
specific lengths were given and everything.
Hmm. Basically,
Can I send
in
it to you
light,
later and then you do it in next class?
uh, yes, you may send that question also because in this ATP section, today we like only discuss about the overview that how ATP questions are look like and what are the important topics that are included in ATP. For light and for planning question, for these two specific topics, we will practice them on individual day because I know light topic is very confusing one, and that is the only question that is confusing in ATP. Because in light you have to draw by yourself, you have to measure angle by yourself, you have to record readings by yourself. Because already the diagram of light chapter is included in theory also. So light section is slightly difficult as compared to journal, thermal, and other topics.
Mm. Yes, it is quite
Yeah.
difficult of the graphic.
So that's why I started ATP. Like today, we only discuss about physical quantities, right? And in thermal physics also, if you check the questions from thermal, like for only light questions, we will practice all the light questions on one day. And for planning question, we practice all the planning questions on one day, right? Because your theory exam is also close and you are practicing, focusing more on the theory. So like one day we discuss this whole scenario and tomorrow like we will discuss about the specific light questions because that is more confusing. In theory, in like thermal physics, you will also get the same type of question. Instruments are given. In electricity, that is another topic. So in electricity, you will also get complete diagram. Sometimes they give you to draw the missing component because in theory part you already studied about the symbols also. In thermal. So this is the latest one. So these are the questions from thermal. Again, you can see magnified diagram of thermometer is given. You have to record the reading. For light, we will discuss all the light questions on one day, right? Like tomorrow. And for planning question, we will discuss like after theory exam because some of you have exam of 10 and some of have on 13. So if you are all feasible, so we will continue like tomorrow we will practice light questions and on the other day we will practice that planning question.
Wait, sir, tomorrow what time?
Same time, 8.
Okay, I'll check
If you have
because I might have some other plans.
okay, so if you have any other class or any other activity, so do let me know in the group also. So I will arrange a class according to that. Because some students have their exam, different exams also. So they are not able to join. So that's why I record the meeting for them also. Because definitely you will get like 2 or 3 days gap between your theory and ATP paper. So that time is also enough for your practice of ATP. So today, this is the journal overview of the ATP questions. And if you want to solve this thermal part, so we will solve this thermal part. Otherwise, tomorrow we will continue with the concept of the light section. It's up to you.
Wait, sir, can you repeat?
If you want this thermal part, this question to be solved, so we will also we can solve this question in this class also related to the thermal. But if you feel that you can solve by yourself,
I can solve it.
okay, if you
Which code is that?
okay, basically in this question, let's see if we continue with this one more question. Because electricity, thermal, and physical quantities, these three topics are like similar type questions. Like sometimes they ask graph in thermal physics also, values are given, and sometimes apparatus already given in the magnified form
Oh,
and
okay, I
have to
found
record
it.
the reading. Plus, in light section, light is completely different from all these three sections. So that's why we have to practice that light questions more as compared to the questions of these journal and thermal electricity question. So basically in this question, a student investigates the cooling of hot water in surroundings with different temperatures. He uses the apparatus shown in figure 2.1. There is a beaker and lid plus thermometer, beaker B, bench, tripod stand, all these things. The water pours 100 centimeter cube of cold water into beaker B and places the thermometer in the water. Measure and record the appropriate column heading of table 2.1, the temperature theta1 of the water as shown in figure 2.2. So basically we are using symbol theta for temperature, not T. So in figure you can see there is a reading, and what is the actual reading in the diagram? This is 15, 16, 17, 18. Right? This is 18 because there are 10 divisions between 10 and 20. So one division is equals to 1, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So we have to put this value in the table 2.1. 2.1 is over here. Okay. 18. Then we have part B. The student places beaker A inside beaker B. And remember, beaker B is filled with cold water. So this is beaker B, and we place this beaker A into beaker B. So beaker A is small, so it can be easily placed into beaker B. Okay. So that the water in the beaker B rises between the sides of the two beakers. As you can see in the diagram, the level of the water rises in it. He removes the lid and pour 150 centimeter cube of hot water into beaker A. He replaces the lid and puts the thermometer into the hot water in beaker A. He records in table 2.1 the temperature theta A of water every 30 seconds. So he records the reading after every 30 seconds in table 2.1. Before that, describe one precaution that can be taken to ensure that the temperature readings are as accurate as possible. So you need to mention just one precaution that can be taken to ensure that the temperature readings are as accurate as possible. So we are recording. Yes, we are using a thermometer, right? And definitely when we are using thermometer, so there should be no parallax error. Always record reading perpendicular to the scale, right? And definitely when temperature increases, just like it is a normal process, if you have to check fever with thermometer, so you hold that thermometer for some time. So reading should be stable, right? And plus one more point, that we are recording the value for water only, right? We are not recording the value of beaker. So your thermometer should not touch that beaker because you will get the reading of beaker plus water. So temperature will be different. So these are some precautions, right? Because normally we use thermometers in our daily life and we know that how to handle thermometer. So you can mention the idea of there is no parallax error, right? And weight. Now you can see these are common precautions for thermometer, right? These precautions are not specific for any question. So these are some precautions for thermometer. You have to write only one. And the student repeats the process for water at higher temperature theta 2. So theta 2 is for higher temperature. Now write a conclusion stating in what way the temperature of the water surrounding beaker A. Temperature of water surrounding beaker A affects the rate of cooling, because in beaker B we filled cold water. So basically if we fill hot water in beaker A, so basically that water in the surrounding that is filled in beaker B try to cool down the water or cool down the temperature of beaker A, because heat transfers to the water in beaker B. Now justify your answer by reference to the values from the reading, right? You don't need to write any theoretical reason. You have to take reference from the values. And from values, you can see initially we have beaker A that is filled with cold water. These are the temperature. And when you filled warm water in beaker B, so these are the readings. So according to the readings, you have to state your answer, what you think about the observations that are taken from this table. So basically, from this readings in the graph, we have to mention the difference what is going on. Basically, at time zero, the temperature in beaker A in cold water is 78.5, and over here it is 80. Then we have 69, 74.5. After some time, if we observe 65. So basically, differences it starts to increase. So in this way, we just solve the questions related to journal, thermal, and electricity.